Wait, so the entire continent is like cracking apart?
Not in a single seismic bang, no. More like
Oh,
a
no.
very, very slow motion rip.
Wow.
And that's what we're digging into today on Milo and Avery. You've handed us some truly fascinating sources, and what they reveal is that East Africa is undergoing this monumental geological transformation.
Monumental feels like an understatement.
Right. We're talking about an entire continent slowly but, undeniably splitting into two. So this deep dive is going to try and uncover the what, how, and why of this incredible ongoing phenomenon. It's a story millions of years in the making, really, and we're kind of getting a front row seat to Earth's profound power.
A new ocean forming. That sounds, well, it sounds epic and terrifying all at once. I mean, when you look at a map, continents feel so solid, permanent.
Mm-hmm.
But you're telling me that's just a trick of our, like, human time scale? That it's actually moving?
Precisely. Yeah, what we perceive as stable is anything but on a geological scale. The main character in this slow-motion drama is the East African Rift System, or EARS.
Years.
Yeah, it's this vast geological feature. Sources differ a bit, but it's stretching anywhere from, say, 2,000 to maybe even 4,000 miles.
That's huge.
It runs all the way from the Red Sea down through Mozambique. And, you don't even need to be a geologist to see the direct evidence of this split right there on the surface.
You mean actual cracks?
Actual cracks. For instance, back in 2005, there was this dramatic 35-mile-long fissure that just opened up in Ethiopia's Afar Desert.
35 miles. Just like that.
Well, geologically speaking, just like that. And then there was that really talked about event in 2018 near Mai Mahi in Kenya.
Oh, yeah, I remember seeing pictures of that. The road just collapsed into it.
Exactly. Heavy rains basically exposed a fault line, creating this absolutely massive crack. 50 feet deep and 65 feet across, disrupted roads, made headlines everywhere. And here's where it gets really interesting. This relentless process, as slow as it seems to us, actually kicked off about 35 million years ago.
35 million.
Yep, up in Ethiopia's Afar region. And it's just steadily continuing southward, grinding through Kenya and Tanzania.
That's truly mind-boggling. So we're literally watching a crack grow over millions of years. And scientists have actually put a number on this slow pace, right? I remember reading it's almost imperceptible,
like human toenails growing.
Yes, something like that.
You're not far off. Scientists estimate the Somali plate and the larger Nubian plate are indeed drifting apart at an average rate of 6 to 7 millimeters per year.
Toenails. Definitely toenails pace.
Pretty much. Which, from our perspective, feels excruciatingly slow, obviously. But what's fascinating is how scientists are constantly refining these measurements.
Oh.
Yeah, some recent studies even suggest this whole process might actually be speeding up.
Really? By how much?
We're now talking about nearly double the previously estimated speed, so around 0.2 inches per year.
Okay, so maybe fingernails now.
Perhaps a particularly vigorous set of fingernails, yeah.
But you hit on something crucial there. The surface cracks are just like the symptom. They're just a symptom of something far grander happening deep, deep below. What's actually driving this plate movement from so far down? Is it, I don't know, some kind of ancient slumbering beast waking up under the continent?
You could kind of say that. Okay, let's unpack this a bit. The primary reason the continent is splitting isn't just surface level stuff. It's about these colossal forces at play, deep within our planet. The continent is tearing apart because of the movement of tectonic plates.
Right, the big plates the continents sit on.
Exactly. Specifically, it's the Somali plate pulling away from the larger Nubian plate. And at the same time, the Arabian plate is also continuing its own separation from Africa.
So it's like a three-way pull.
In one key area,
Yeah.
It's a complex system, especially in the Afar Rift Zone up in Ethiopia. That's a rare geological spot where 3 tectonic rifts actually converge. The main Ethiopian rift, the Red Sea Rift, and the Gulf of Aden Rift. It's a major junction.
Okay, so plates are pulling apart, but why are they pulling apart there? What's the engine?
The engine. The key driver here is thought to be something called the African superplume.
Superplume. Sounds impressive.
It is. Imagine this colossal reservoir of molten rock, like a giant hot blob rising up from the boundary between the Earth's core and mantle, way, way down.
Okay.
The superplume is actively thinning the rigid outer layer, the lithosphere, from underneath. And it's pushing those tectonic plates further apart. It's not only driving them apart, but it's also literally elevating the entire continent by hundreds of meters, like a massive hydraulic lift from below.
That's incredible. So this superplume is like the Earth's engine for continent building. Or, I guess in this case, unbuilding.
Precisely. And what's truly remarkable is that scientists think this superplume kind of pulses.
Pulses, like a heartbeat.
Almost, yeah.
Ah,
And these pulses carry distinct chemical signatures. It's not just theory either. They have compelling evidence.
like what?
Well, a big team, like 10 institutions, analyzed over 130 rock samples from volcanoes all over the Ofar region and the main Ethiopian rift.
Okay.
And other advanced geochemical studies, looking at stuff from geothermal fields like Kenya's Menengai, have backed this up. Both analyses provide strong evidence pointing toward a single huge superplume as the common deep mantle source beneath the whole East African rift system.
A single source for that whole huge area.
Seems like it, and its chemical fingerprint is strikingly similar to Hawaiian volcanism.
Hawaii, that's a wild connection, Hawaii all the way to East Africa.
It is, but both are thought to originate from mantle plumes, these deep upwellings. So the chemistry matches up in surprising ways.
Okay, so how do scientists even test theories on this kind of scale? Do they, like, build models? Or is it all computer simulations?
Good question. It's actually a combination of things. They use physical analog modeling studies, for example.
Analog modeling, like with sand and syrup?
Sort of, yeah, but obviously more sophisticated. Models like those help explain how structural inheritance affects things.
Structural inheritance.
Yeah, it's the idea that existing ancient weaknesses in the Earth's crust, old fault lines, thinner spots from past events influence where new stresses break through.
Ah, like the Earth has geological scar tissue.
Kinda, yeah.
Yeah.
These models also support things like the clockwise rotation of the Somalian plate and how the rift seems to be propagating or spreading, generally southward. It's like the superplume is finding the pre-existing weak points in the continent and just exploiting them.
So what does this all mean for, the map in the future? Are we talking new beachfront property in Ethiopia anytime soon?
Well, don't hold your breath for coastlines appearing overnight.
Ah.
Scientists estimate the really dramatic process, the actual forming of a new ocean basin, could take anywhere from, say, 1 to 5 million years.
1 to 5 million. Okay, so not next Tuesday.
Definitely not. The one source we saw did mention tens of millions of years. So,
Yeah.
it's definitely not happening in our lifetime or even our distant descendants' lifetimes.
Right.
The ultimate vision, though, is that the Indian Ocean is expected to eventually flood into that rift valley.
Creating a whole new
A
ocean.
brand new ocean, yeah. And potentially separating parts of Somalia, Kenya, Tanzania, and Ethiopia into maybe a new, smaller continent or perhaps a series of large islands. This new ocean will properly be born when the Gulf of Aden and the Red Sea eventually connect up and flood into the East African Rift Valley.
But imagine the geopolitics of that. I mean, forget the geology for a second. Landlocked countries suddenly getting a coastline. That's not just a map change, that's a whole new world order for things like trade and resources. Think about places like Uganda, Rwanda, Burundi, the DRC, Malawi, Zambia, all currently landlocked.
Yeah.
They could gain direct access to the sea, build new harbors, connect to the global economy in a totally different way. And what about the East African Great Lakes? They hold, like 25% of the world's unfrozen freshwater already?
That's right, a huge amount.
They could potentially connect to this new ocean, fostering entirely new kinds of marine biodiversity, mixing freshwater and saltwater ecosystems, maybe? It's a huge shift in potential.
Indeed, the opportunities seem immense. However, we also need to look at the challenges and the potential downsides. Various environmental assessments raise some serious points.
Such as?
Well, those Great Lakes. They're already under considerable pressure from human activities. We're talking pollution, unsustainable fishing. It's a critical concern because of the high human population density around them.
Right, problems we already have.
Exactly. For instance, Lake Victoria has already seen the extinction of hundreds of native cichlid fish species, partly due to introducing the invasive Nile perch and partly due to severe eutrophication.
Eutrophication, that's like algae blooms from pollution.
Yeah, basically excess nutrients, often from runoff, cause dense plant growth, which then depletes oxygen and harms aquatic life.
Yeah.
Lake Turkana, another example, faces severe freshwater shortages,
Why is that?
mainly because of big irrigation schemes diverting water from its primary source, the Omo River, plus damming projects upstream.
So adding a giant influx of salt water isn't necessarily going to be simple.
Not at all. While a new ocean sounds grand, that saltwater influx could erase existing coastal villages, totally disrupt delicate freshwater ecosystems that exist now, and require huge adaptation from regional communities. Think altered local climates, different agricultural patterns.
It's a massive upheaval for the people living there now or their descendants in the nearer future.
Absolutely. And this isn't just an African story, is it? These kinds of massive geological changes, they don't just stop at continental
Oh,
borders.
the whole planet is connected.
Exactly. There's a potential global impact to consider. If a new ocean forms, the planet's worldwide ocean currents would eventually shift.
And ocean currents control climate.
They regulate global weather and atmospheric systems in huge ways. So the climate patterns across the entire globe could alter over time. This would force humanity everywhere to adapt new temperatures, different rainfall levels, maybe changes in storm severity or frequency.
And like I worried about earlier, that could be devastating for communities or even whole nations that lack the resources or, frankly, the political will to adapt effectively.
Mhm. It forces this planetary scale reevaluation of how we build and manage our societies when faced with such profound, albeit slow motion, change. But, this isn't just about Africa splitting. It's really a profound reminder of our planet's incredible constant motion. We've seen this drama play out before, countless times.
Like how South America and Africa used to be joined.
Exactly. Look at the Red Sea, for example. That formed when the Arabian Peninsula drifted away from Africa millions of years ago, a very similar rifting process. Or, as you said, recall that a comparable geological process once separated the African and South American continents. That led to the formation of the Atlantic Ocean as they pulled apart. The breaking up of ancient supercontinents, like Pangaea, was also driven by similar forces deep within the Earth, including these massive plumes, these superplumes. It shows Pangaea wasn't necessarily some unique one-off event. The Earth is always doing this.
It's humbling, isn't it? What seems like a sudden crack or a dramatic event to us is just a tiny blink in the Earth's long, evolving story. It really makes you wonder how much we can truly claim to understand or, predict about our planet's long-term future. And what should that mean for us living on this constantly shifting surface? Does it change anything?
I think it has to. What we are witnessing in East Africa is more than just a geological event. It's kind of a preview of planetary rebirth in a way. It just underscores that our Earth is this dynamic, living system, perpetually shifting, cracking, transforming. It's a powerful demonstration of forces far beyond our immediate comprehension, yet they're directly shaping the world we inhabit, albeit on a timescale that truly dwarfs human existence. So here's something to think about. If continents are constantly reshaping, and what we consider stable is actually fluid over eons, what does that mean for how we build our societies, our infrastructure, even our whole understanding of permanence? And after all that, it's clear the Earth isn't quite done rearranging the furniture.
But I wouldn't have it any other way. See you next time on Milo and Avery.